Hi, today we are going to present you about binary search and insertion sort algorithm. First, let's reintroduce ourselves.
Hi, my name is สศิธรแก้วตั้ง
Hi, my name is ธีรพัฒน์ขนดี
Hi, my name is Pithiya Nama.
Hi, my name is Panuvachayaban.
Hi, my name is Chanawat Chumpulak. Binary search algorithm. Search algorithm. A search algorithm is the step-by-step procedure used to locate specific element among a collection of elements. Type of searching algorithm by mechanism, linear, binary, and hashing.
Binary search. Binary search is an algorithm used to find an element in a search list or array of elements. The basic idea is to repeat divide the element in half until the element is found or determined to not be present. Binary search step. Step 1. Identify the middle element of the search list. Step 2. Compare the middle element with the target volume. Step 3. If they are equal, the search is finished. Step 4. If the middle element is greater than the target, search the left half of the list. Step 5. If the middle element is less than the target, search the right half of the list. Repeat step 1 to 5 until either the target is found or the search space is empty.
Insertion sort. Sorting algorithm. A sorting algorithm is an algorithm that puts elements of a list or array in a certain order. Some of the most common sorting algorithms are selection sort, bubble sort, insertion sort, and others.
Insertion sort works by taking unsort element one at a time and comparing it to other elements on the left side until the algorithm finds the element that is smaller or has the same value as the sorting element, then inserting the sorting element into the correct position. This process is repeated until the list is fully sorted. Time complexity O n power 2. Stable sorting algorithm can have same value elements. Real world example in a jigsaw puzzle, sorted elements are pieced, they are locked together, and unsorted elements and scattered pieced.
Insertion sort step. First, start from the second element of the list. Compare it with the first element. If the second element is smaller than the first, shift the first element to the right and insert the second element to the empty index. Else, the element sort to stay at the same place. Move the first element of the unsorted side. Compare the first element of the unsorted side to the last element of the sorted side. If the first element of the unsorted side is smaller than the sort one, shift the sort one to the right and repeat it until algorithm found the elements that are smaller or equal to the first element of the unsorted side. If found the element that is least or equal to the first element of the unsorted side or out of index, then stop and place the first element of the unsorted side to the empty index. Repeat step 3 and 4 for all remaining unsorted elements in the list. And this is the end of our presentation. Thank you for your attention.